To deal with noise in communication, error correction coding can be used. Hardware realization of ECC circuit is implemented by transcribing C to Verilog for the sake of minimum efforts. The Verilog circuit can be synthesized into physical layout photomixes on Caravel SoC platform, synthesizing and hardening the circuit into GDS layout. The various layers of masks can be visualized in 3 dimensions in GDS 3D app. The ECC circuit is validated through logic simulation. Let's go back to the original state and go through the synthesis steps. With Caravel platform up and running, let's implement the ECC circuit on the Caravel SoC. Go to Caravel user RTL directory. In hardware realization, optimal design of the ECC circuit can be done with constraints on execution speed, real estate, power consumption, etc. Nevertheless, an interesting high-level approach can be taken for the sake of minimum efforts. Art of ECC site contains generalized result on ECC encoding-decoding in high-level C language. Let's directly transcribe ECC code from C into Verilog. Define the input and output signals to SoC. The ECC code consists of 2 modules, encoder and decoder. The encoder takes in user messages and adds redundant ECC to it, and vice versa for decoder. At interface level, define encoder and decoder circuits. The ECC encoder is a sequential state machine. Let's define the state register storage. Implement state transition and state output. Encoder states are straightforward with ECC calculation and ECC result outputations. Allow reset to the state. The output signals are the results of algorithm execution. The output is the results of linear feedback shift register operations. Move on to decoder Verilog. Start with state registers. The decoder uses sequential states including syndrome evaluation, Berlekamp-Massey polynomial constructor, and chain search error locator. Syndromes are evaluated with roots of generator. Berlekamp-Massey algorithm uses Gerardian identities to transform syndromes to the error location polynomial. The polynomial is constructed through iterations by reaching a state of zero discrepancy. If discrepancy is not zero, then go back to the previous good polynomial and add the discrepancy to it so that there's no more discrepancy, and continue. The algorithm would find a polynomial that results in discrepancy of 0 for all syndromes. Otherwise, it would declare the code is not correctable. At upstream module starts the VM and waits for the completion. Chain search locator finds the roots of the error location polynomial, which can be used to make correction to the data. The error correction code in Verilog in RTL level can be synthesized, placed, and routed into GDS photomatics. It is synthesized through steps of user's ABC RTL synthesis, OpenSTA gate level static timing verifier, open row floor planning, placement, clock tree synthesis, antenna fix-up, global routing, trend route detail routing, and physical verification. The error correction coding circuit is integrated into Caravel SoC. Run precheck to check for GDS, netlist, GPIO, DRC, constraints, etc. The layout GDS can be visualized in 3 dimensions in GDS 3D app. The Verilog ECC circuit is simulated. Install GTK Wave for parsing and displaying the simulation results. Look at the simulation. The user data to be transmitted is 4B in hex. To encode this 7-bit user data into 15 bits code word, the encoder circuit is used. From the output of the circuit, the data are 4B57. To exercise the decoding circuit, inject 2 errors to it. The data with errors are 4F, 5F in hex, and it is sent to the decoder. The input data are evaluated to syndromes. Subsequently, syndromes are transformed to error location polynomial, and the polynomial roots are used to correct the errors. The decoded data are 4B in hex, which is what we expected. The code is checked into the GitHub repository. That concludes the presentation. Gracias. Hasta la vista. Adios.